This conference will now be recorded.
Okay, so let me share my screen. Let's see, here we go. Okay. Right, and also so people can see me. So for today, I want to give you all an update on what we've been doing for the last couple months in the ODSA business workstream. And this is going to be both kind of a quick recap on where we have gone with our thinking, and then some more information on our latest project, which is to write a white paper about business considerations and helping people make decisions whether it makes sense to build a product with a chiplet architecture or whether to do it in another way, such as using a monolithic design. So before I get, point out, okay, it looks like, before I get too much into the details, I figured it would be good to give people a quick context. The business workstream has been active in the past. I haven't joined it for a while, so I don't know like exactly what happened, but I know some of the previous efforts and the outcomes there, and I figured it would be good to quickly review this with people and just mention that this work is already out there. There was a white paper written about challenges and opportunities of an open chiplet marketplace, and there was also a great work done around a chiplet cost model to understand basically the trade-offs from a financial perspective of implementing chiplets, the benefit that you get from higher yield of smaller die, and so on. And so there's actually, I linked out here 3 things that people can follow up with. There is an IEEE paper that looks more at the math of the calculator. There is this spreadsheet calculator itself, and I think possibly even like a Python version. And then there's also a talk about this whole project that takes people through a little bit through this calculator and talks about the background. So, but after those outcomes, there was a bit of a pause in this work stream, and earlier this year, it looked like there was renewed interest. So we had these several talks from companies in this meeting about business challenges, and those were just 15 to 30-minute talks from 9 companies that talked from their angle what holds them back to implementing chiplets in like or to achieving this open chiplet marketplace, and that really triggered to revive this working group. So I wanted to take a moment to just review the outcomes of these 9 talks. Here is, and this is something I shared before, but in case somebody had joined or hadn't joined those previous meetings, this is just, I'll send out all these slides afterwards, and then people can follow up on their own if they're interested. So this is a list of the talks that we've had in this forum, and links to the YouTube recordings and also the meeting minutes. And so what I had done afterwards was to scrape through these short presentations and try to find commonalities of what are the things that may be unique to a certain company, but also what are the things that many people are asking for. And because this was all free form and like it took some effort to understand, like even if people word things differently, do they ultimately mean the same problem? But my attempt at solving this was to cluster things around basically common themes and then count how often those have occurred. And I had grouped this roughly into 3 categories. I mean, all of this was business at the highest level, but even within that, there were some things that to me were very much like business and cost questions. The one that had the highest number of counts based on these talks was fundamentally something along the lines of the cost benefit of using chiplets versus a monolithic design, and any overhead that you may have to account for. And then the second most mentioned thing in this category to me was the product schedule uncertainty and risk when going to chiplets. Then another category was addressing a chiplet marketplace with questions, for example, around third-party chiplet availability. And then the third group that I'd mentioned here is technical, but as I said before, this is kind of at the intersection of business decisions and technical. And what has been mentioned, the most number here is the question around what die-to-die interface to choose, followed by things like what packaging options one should deploy, and questions around standardization for link layer, power, aspect ratios, and other things. So this was very much a precursor to what we can do in the business group to address these. So after having gone through these topics, we formed this business group. We had, I think, like fair amount of interest from people. I think on average we have something like 6 or 7 people now joining, with some regulars and some people poking in every once in a while. And when we started this business group, we looked at a couple of things of what we like, meeting things we can do to contribute to this community and solve some of the issues that were highlighted in the talks. And I quickly want to recap those ideas. Not all of them we're working on right now, but it may give people an idea of like if they're passionate about one of these things. The first thing that we had come up with was an idea to define top chiplet use cases and then look at the challenges of implementing a chiplet design in a specific use case, such as, for example, for a mobile space, like for 5G or 6G or high performance computing. That was one idea. A second topic we had was to basically write up all the information that we've gotten from these various companies and make a white paper out of this, to first explain these challenges in more detail, to also possibly sort them by when these problems come up in the value chain of designing a chip and bringing it to market, to cross-reference this with material that already exists from the ODSA and other entities, and to also try to capture the difference between using chiplets as a strategic commitment rather than just dipping your toe in the water, like, which means maybe trying out an interface but not really pivoting your whole design methodology to chiplets. A third item was, or third thing that we discussed was to work out or help with chiplet compliance. That was one of the things that came out of these discussions. And one way to tackle this would be to have a checklist that helps you evaluate compliance. There are questions around what kind of information are companies willing to share, and also the idea of self-compliance or thinking about third-party compliance testing came up. We then had a fourth proposition was to look at business case best practices. So this is going down the road of what we're doing today, basically capturing a way to, or developing a methodology on how to evaluate whether to build a chiplet or a product with a chiplet architecture or as a monolithic design, to summarize best practices here and look at failed attempts where possible. A fifth idea was around chiplet proposals for the CHIPS Act, and we had a couple ideas of what could go into those proposals, but this was something we didn't further pursue in the end. And then lastly, as something that a few people brought up, was a question on how we can organize the information that has been generated as in these various work streams from the ODSA to be better organized and more easily accessible. So after working out these ideas, we took a vote on what to do, and this is the outcome of what people were voting on in the business group. I had set this up in a way that you could just basically call out priorities of all of these things, and maybe some people think everything is important, but in the end, you should look at the high yellow bars, which means that people called this out as being high priority for them. So what was number one here was building these list of chiplet use cases and then analyzing challenges around that. And the second one was on business practices or best practices for developing a business case. So we had then spent probably a month or even more on this first item, and we started looking at the semiconductor market, where chiplets will likely play a big role. And we even narrowed it down to a kind of a more constrained use case, which was, let's think about the two chiplet platforms that have been discussed here in the ODSA before, from Fraunhofer and Samsung, as well as from Dreambig, and try to understand, can you, like, what is the difference between designing your own ASIC versus leveraging that platform and just developing an additional chiplet to build the system that you want. And I think what we came to conclude in the end was that it's, in order to make this decision, do chiplets make sense or not? It depends very much on the specific use case that you're looking at. And in order to make that call, you need the right information to say, yes, there is a benefit, or no, there is not. And we, as a group, and with public information available, we didn't have that kind of access. We could have worked out possibly something like a framework, but then leave it up to individual companies to check with, for example, their suppliers to fill in all the information to make that call. But so in the end, we realized that is not the right way to go, or if we just present like a general framework there and assume some information which will have a large error bar, then the outcome will also have a large error bar and becomes meaningless. So you won't be able to say with certainty, should you have done chiplets or a monolithic product. So then that basically moved us more towards a combination of here the second choice and combining that, or like writing a white paper about that. So in between, we had, or before we then converged on the white paper, we had a couple of other like more philosophical discussions, and because it's such a big topic, and talking about just a business case overall, there are many aspects to it. So I figured like just putting down two of the things that I found helpful for myself. The first one was motivations of why people use chiplets, and I know this is a topic that is basically in every chiplet paper. It's usually the beginning of why should you care. But we took that a little bit more to heart and tried to understand in the literature today what is adequately covered and what is not. So the three main use cases that I can see are this idea of using chiplets to increase your yield by making the individual die smaller, and that basically gives you higher yield and hence a smaller bill of material cost. Another way of using chiplets is to use different process nodes, which you can either use to lower your bill of materials by putting some circuitry that doesn't need the most cutting edge node to move that to a lagging node and basically save on silicon cost, while not drastically increasing your die area, for example, for analog heavy circuitry. The other one could be that you do these different process nodes to increase your performance, such as going to choosing nodes that are optimized, for example, for RF. And then the third use case is this idea of using chiplets for modularity and using it to address a high mix and low volume market. So here your main benefits would be that you can, like, if you have this library of chiplets, you get the shorter time to market and the lower development cost, which makes addressing this market feasible in the first place. And so I think what came out of these discussions is that we said this first use case here, the higher yield is something that has been discussed plenty in literature, and there are companies living this today, such as Intel or AMD, or even Xilinx in the past. So we didn't see too much value in just repeating what people have said there. On the other hand, this question of this modularity for high mix, low volume, and especially for, say, markets and products that are not in the hundreds of dollars, but significantly less than that, we figured that is an aspect where chiplets as a methodology seem to have a lot of promise, but there is, at least to us, no clear, let's say, indication of how to measure that, or like how you make that decision of whether chiplets make sense for, say, a $5 or $10 product, because of course there are tons of influences or tons of factors going into that. So we figured that would be a nice starting point for this paper. Another, I think, aspect that came out of this discussion is the way that chiplets will be adopted in industry, and I like put down these like three different options here, which initially I saw as a progression, but it's probably like a more complicated space, but you have the option of chiplets being first used by larger companies that are vertically integrated, so not necessarily for sale, but to help with basically making a product portfolio more modular. There is so this is what we're seeing today. There is the next, I think, frontier that's attainable is to partner with several companies to partner so that you have NDAs in place to be able to share all the information necessary to build chiplets that are compatible. And we're seeing that in industry today. And then the third part, which is the goal of I think a lot of companies, is this open chiplet marketplace. Um, there, it probably won't be like the question is how will that come about? And like my personal take is startups here have an interest in basically opening it or starting this to offer technology that is not widely available otherwise. And there's a question of how larger companies will follow, or like the number of chiplets they will open in a marketplace without undermining their own market that they already have. But again, coming back to what can we do to help in the end go to this open chiplet marketplace, I think it is on the one hand helping companies decide whether chiplets make sense for them even internally, because once you go down that route, I think it's going to be a lot easier to then sell a chiplet in the long run when it has been first developed for internal use. So that would be one way, but the other one is also to help startups or any company that wants to go to this open market right away to understand the dynamics and the constraints around that. So this brings us to our current effort, this white paper that I already mentioned. And I've set these points basically before, but just again to summarize, the goal of our white paper is to summarize all the considerations going into planning a chiplet product and making the decision of chiplets versus ASIC. And this would then help companies justify chiplet development and, in our hope, kickstart more of a chiplet economy. And in terms of audience, the best way I could describe this was to address this towards business people or product managers. Maybe there's a better way to term it, but at least the goal is to get to people that may not have the full technical understanding of what you need for chiplets, but that are required to sign off on deciding whether you go a chiplet route or not. I wrote down the scope of our paper. I think this is something that has emerged again through a lot of the discussions, and I've brought up many of these points before. So explicitly in scope is to look at chiplet use for vertical integration, to look at chiplets for the sake of modularity and supporting high mix, low volume products, to also consider how the cost and performance benefits of using different nodes, put an emphasis on this lower ASP restrictions, because at least in my experience and also many others on the call, there are different rules when you're looking at building or trying to use chiplets for something that is less costly than what you have today. And then the last one is business aspects for an open chiplet marketplace. And so what we phrased as out of scope is the idea of chiplets for yield reasons, because it has been addressed so much, and also chiplets for very high ASPs. So I'm talking about the kinds of GPUs and AI accelerators, which I think is again a place where chiplets are becoming more visible already, because it's easy to prove financially that it makes sense for you. But we're trying to add additional insight into areas that have been less looked at so far. So then lastly, this brings me to the outline of the white paper. So this is something currently in progress, and I've marked some of the sub-bullets in green, which is where we have started drafting. We currently have, I think, 6 or 7 people involved in contributing to this. So let's look at the structure, how we want to write this. And then I think this would also be something that I'd be very happy to get feedback on, like things that we're missing or things that people may want to contribute. So the first part would be just an introduction, but a short one, not necessarily regurgitating everything that people have said about chiplets, and rather opting to reference good articles and papers that summarize the essence of chiplet design. And then I think importantly the scope and trying to define how our paper takes a fresh look at some of these aspects. A second part would be focused on chiplet cost structure. So this is kind of the heart of the financial discussion of why should you do chiplets. At least in my personal conviction, if you look at return of investment holistically, it needs to make sense to use chiplets. And there are some things that are easily quantifiable, such as your development cost and the unit cost. But just walking through all the items that go into it. But then you have a little bit more nebulous things like opportunity cost of going to market faster, or this potential of having built out a library of chiplets and now being able to service new opportunities that otherwise wouldn't be able to stand on their own, and trying to also put those into this holistic ROI discussion, and maybe giving people an idea on how to quantify it. And then also adding where maybe case studies or examples of where chiplets have not succeeded, which I think is equally helpful. A third part is, I would say, more for informational purposes, chiplet architecture. And by that, I mean just the various ways in which you can leverage chiplets. This would be, on the one hand, using different process nodes for, say, cost savings or for increasing performance. And also the second option, having a homogeneous system where you may partition your system by, say, an individual unit that you want to scale a couple times. That is one way. The other one would be to do more of a functional partitioning, where you, say, separate your AI accelerator from your compute subsystem from something like an I/O block, and then you think about, can you reuse these chiplets in other products later on. Number 4 is focused on packaging. I personally think this is something that is helpful to tie to the rest of the discussion, because at least when you go to, I'm repeating myself here, but when you go to these use cases where the whole product cost is less than $100, packaging, even smaller increments in packaging cost, will make the whole business case fall. And so just understanding the different options that you have available and what the constraints that they come with in terms of, for example, the line in space that you can achieve in a certain laminate technology, and then kind of cross-linking that to the types of interfaces that you can use, I think that really helps people work their way up to a business case. And one other option here would be to map out these packaging options to rough price ranges, even if that is empirically done by saying, well, if we look at products today that cost this much, they typically use this and that kind of packaging. Number 5 would be around probe and test. So we would want to, of course, explain the importance of known good die testing, but also give people at least a glimpse of the items to consider, such as the number of tests that you have to do on all your chiplets before you can build a system, the time on probers, as well as the cost of these probe cells, even if it's just relative costs. But I think that will help people understand that there is more that you have to add in terms of, well, first effort, and then also equivalently cost, which just impacts the discussion on, do chiplets make sense or not. And then lastly, something about testability in general, and strategies where maybe you can look at things like loop-back testing, having sacrificial pads for probing, or having built-in self-test. Number 6 would be on the open marketplace, and items that we have discussed so far that we would like to include is a discussion on interoperability, maybe a short discussion also on feasibility of bridge chiplets, or at least discussing that idea, and then talking about the economic framework. And then lastly, we want to include a section on chiplet standardization, both for interfaces, but also for all these other formats that are being discussed in this chiplet design exchange. So I know that was a lot of information. I'm happy to get feedback on, I guess, what we're doing in general, but also specifically this white paper, because I think there's value in hearing if you think we're going the right way, or if there are things that we should change.
Hey, Marek. Thanks very good. Thanks very much.
Do
That's a
people
good,
have any? Yeah.
yeah, good overview. Firstly, apologies for missing the last few meetings. But I guess what I want in listening to you and taking a step back, um, I've actually been working with a number of companies that have been considering chiplets, and it pretty much ends up being unanimous of there's a lot to sort out, as you've identified here, right? And everybody is very gun shy,
Yes. Yeah. Yeah.
uh, and so they all end up saying we'll wait and see, right? So we've got this problem of people actually getting started, and and something just struck me during your presentation that because there's too many unknowns, everyone's worried about getting started, but they agree with, I think people can quickly agree with your arguments, or the arguments we've been putting forward over the years. But there's still just, it's still there's so much to be done. It's very difficult unless you're fully vertically integrated. So, but what really struck me is I'm obviously from the FPGA world, and the FPGA model was really quite interesting. It was a case of everyone said FPGAs are too expensive. I'm going to do my own ASIC. And the selling mantra of FPGA companies was, hey guys, start off with your prototype with our FPGA. And as soon as you get to production, make your ASIC when you're much more confident about your design. And what the FPGA guys actually succeeded in doing is you would capture that lower volume market, and you would capture people that were saying your FPGAs are too expensive. They would lower their price to stop them converting to an ASIC. So, but it was quite an interesting way for how the FPGA companies actually got people to use their technology. And so, in my mind, when you're creating these quite complex monolithic, so the people I'm working with are saying we're going to wait out. We're just going to wait it out until this industry gets established. But if we sold it as, hey, this is a fantastic prototyping platform where you can very quickly build your monolithic chip as a prototype and maybe sell in low volume because you're worried about known good die, or you put 5 die together and one fails and costs you a fortune. It's going to cost too much to make a product out of it. Go with the path of you're going to make your own die. You're going to make your own monolithic die, but you're going to build your first prototypes by going to those IP vendors and saying, I'll have your PCI chiplet, please. I'll have your memory chiplet, please. I'll have your this chiplet, that chiplet, your heterogeneous chiplet. You put your prototype together in the package, and maybe you can get a really fast time to market with this package part, which is a lot more expensive than your final ASIC, but it gets you to market quickly. Your own custom die compared to other people's dies, you can iterate when you get bugs in it much more cheaply and quickly, so you can get your product to market faster. And so if you can get the selling of that, maybe these companies that I'm talking to that are saying, I'm just going to carry on with my monolithic die. I love the idea, but I'm not going to be the guinea pig, to suddenly changing their mind and actually saying, actually, I can get my product to market quicker. Yes, and I can take risk off the table. So I can improve, I can lower my development cost, and I can have a faster time to market. And therefore, I'm going to jump on the chiplet bus now. And the key ingredient in my mind for that is the chiplet companies are the IP companies. So they come from the world of selling IP at great expense to selling cheap chiplets, and then being able to get the IP into a monolithic die later. So anyway, it's just maybe a strategy of getting started. It's a getting started strategy, which I think is the biggest hurdle that I'm seeing with everybody I speak to that are interested in chiplets.
Yeah, no, agreed. I think it's a really good point, and it would be. I think there's like the like half a step before that, which is where do you get those chiplets from to prototype? And if the answer is, well, you have to build them all yourself, and you compare that to just building your own like your own chip, that doesn't make sense unless you
No.
say, well, I'm willing to give this a shot for a while, and even within my ecosystem, I'm going to reuse it to prototype, and at that point, trying to make the argument for it may still make sense.
Yeah, exactly. But in my mind, all the IP vendors, they all make their own IP in somebody's foundry or multiple people's foundries to prove their own IP works before they sell it to us. So therefore, it does come down to agreeing on the interface for sure, right? Like, so that we can plug these things together. But all I'm saying is it might be a better way to break this thing up because everybody's looking at all of the things that need to align beautifully for this industry to start, this
Yeah,
ecosystem to really start. But this might be a way of piecemealing it a bit more. And if I'm an IP company, by the
yeah,
way,
okay,
yeah,
yeah,
it's best for the IP companies in my mind. I think it's a great model for these small little IP companies to be able to sell a chiplet as well as their huge IP block that costs $500,000 or $1 million to even start. You can buy their chiplet for $100 to begin with, and then you buy their IP when you want to make your monolithic die.
right. To almost think of it as a like sampler type strategy for IP companies that say like you don't even have to go through integrating it. Here's the block with like a bunch of wires to UCIe, plug it into your system, see if it works, and then come back if you want to build it later.
Yeah, the IP customers, if you look at all these small IP customers, they're feast or famine, right? If they can get somebody to design their lovely piece of IP into a chip, suddenly they get $1 million check up front, and then they get their royalties and they're off to the races. But if they make a chiplet that smaller companies can use for $100 or $200 a chiplet or whatever it costs, they've got revenue stream
Yeah,
from selling the chiplets for the low volume applications, but they also have a selling tool for selling their IP into a monolithic. If that company is saying, we only want to use your chiplet for prototype, and then we're going to use your IP for our own monolithic ASIC. So I'm just saying, take a leaf out the FPGA guy's book,
right.
actually market and sell this, and just be humble.
Yep,
Yeah,
that's
they're
true.
chiplets are
That's a
just
good
for
idea. Yeah.
just be humble. Chiplets are for prototyping, not for production. And then you'll get some production in the low volume, and then you're off to the races, like the FPGA guys did. So,
Okay. Thanks.
Yeah, I was just I know that Bapi was saying that they're gonna have a place to show a bunch of chiplets, right? So um, who are these chiplets? And because I've looked around and I can't buy a chiplet, so I think there's this whole disconnect um, in this whole mess, right? Um, there's some people saying, hey, there's all these chiplets in flight and whatever, and there's an economy coming. And the other
Yeah.
thing is I think Alan pointed out, a lot of end customers are like, well, how do I get there, right? And yeah, so is someone trying to get this thing going? I mean, I think that it would be good. I mean, I think if there are 5 companies that are ready to show something. I mean, I've seen D-Matrixes at the Chiplet Summit, right? And we know Ventana has something, but can you buy those chiplets? I mean, I actually don't know. I mean, I'm just like, um, there's, or have they just done a prototype? I mean, just doing a prototype is of no use to anybody if you can't buy the darn chiplet, right? As Alan is saying, hey, when you talk to a customer, they don't
Yeah.
want to see all this crap. They want to know, well, can I buy you a chiplet? And then the answer is, well, you know, uh, no. And I think that's really the issue, right? It's the end customers are more than happy to go to market faster and save money, right? But there's this huge chasm of how do you get there, and I don't think that um, uh, we're on the right path. That's just my opinion.
Yeah. No. Thanks for your comment. I mean, you're contributing yourself a lot to the group, and that's exactly kind of why I personally think if we can start making the argument for companies on their own, then to me that's a powerful way of using chiplets as second use in a marketplace. But if you can't even get people to do that, then it's going to be even harder to just start outright with the open marketplace. Other
Well,
thoughts or questions?
I think it is, at least I'm trying to sort of walk away from a rigid notion of a marketplace and simply say reducing the friction of building chiplets. And to me, that's the sort of big difference between a chiplet economy and a marketplace. A marketplace implies like I can buy something, it'll all work magically together. Whereas I think at least for the next couple of years or 18 months or so, we're in the business of reducing friction when you're building a chiplet. How do you get people to build their own chiplets more easily than having to reinvent everything themselves?
Yep, agreed.
Um, so there was an interesting comment on Monday or I'm trying to remember, the Monday or Wednesday at Semicon, and it sort of aligned with us with that there. What is interesting is there's some places where we have many standards like the protocols for die to die, and then there's some places where we don't have any standards at all, like in chiplet sizes, package sizes, chiplet thermal guardrails, chiplet chiplet power delivery guardrails. It was interesting. There's a guy from Light Matter who sort of poked his head up and said, "Well, those would be really useful because we're finding that to be an actual challenge when assembling chiplets, not providing people with guardrails and standards on that help packaging and assembly." So there's a lot of standards on interop, but not no, very few boundaries on limiting hotspots, limiting the maximum amount of power your chiplet can draw, limiting its size, limiting the package size into which these chiplets slide into, etc. So it'll be interesting to also have a third section on where we possibly need more standards. Personally, at least I'm dead certain based on the feedback that there are gaps on packaging and assembly for sure.
Yep. No, agreed. I guess, and this goes. I mean, you've mentioned this in your talk last Friday. So, like, I think that would be great to include, and if you possibly, like, if you have that as a thought, like, kind of ready and laid out, then it'd be great if you could contribute that, if you think that's possible.
Yeah, so we've got this big fat paper, but yes, I think so. But that's a place where we do need more. That's an area in my head that where you do need more standards. And
Yep.
it was interesting. There's one more comment, which is like you can't do burn-in test easily with chiplets because you can only do burn-in tests on the fully assembled product. And if when you're doing burn-in, one of your chiplets is more likely to fail, you're pretty much losing the rest of them as well. And so people are looking at sort of very clever ideas on how to simulate the same effect as burn-in on a chiplet by changing the way they do structural test. So there's a couple of how do you put it? Because of the constraints of chiplet-based products, they're changing the way individual chiplets are tested because there's certain things you can do with monolithic that you can't do with chiplets.
Okay.
Um,
Yeah. No, that's a good point.
any other questions, thoughts?
No, the only other thought I had was that I think the business group is missing a packaging person or somebody from the packaging guys because I think that's at least from my perspective, that is a huge cost factor and complete uncertainty on what's available, what's coming, what fits so it would be really helpful to have somebody from that space attend our business meetings, I think, or help on the business side.
Well, we actually have Trent there, and he he's a packaging engineer, and he did put in like a long section on just some of these bullets that I'm highlighting, which I'm going through myself, and I'm like, I think we may need to put some of that in an appendix because it's very detailed, but also super helpful. So I think we have that person already.
Oh, okay. I haven't seen what he sent.
Yeah,
Okay.
no,
So
he just put it in yesterday. So there's a
okay.
this is for us to discuss afterwards.
All right. Okay. Perfect. That's great.
Hey, Marek, if you, it's a bit of an unfair question, but
Yeah.
even maybe not necessarily an answer right now. But if you had to summarize the before and after of this white paper in your mind for the reader, what what would they sort of get in your mind that is missing on, say, a survey of standards or a or a UCI pitch or a bunch of wires discussion? What
I
or
think
the previous business paper?
the first one that I would like to have come across is that like just picking say UCIe or a bunch of wires or like another standard is connected to many other choices, and to at least see those connections and then likely go to the appropriate people to understand that further and pull those people into a team if you want to make a decision. But at least that's what I found is necessary to like show all the connections when you're trying to make a case. And then I think for the standards, like the missing standards, it's like ideally maybe bringing it to people's attention if some companies or whoever has ideas on how to solve this, or maybe even internal ways of addressing this already, then this could be a seed for like having some kind of standardization process or bringing it into like organizations like this. But yeah, I think at the highest pace, since we're touching on so many aspects, there will like definitely not be room to address all of these adequately. But I think I would like at the first level for people to have an awareness of the different things that play together, and ideally as many either like additional discussions that could be in an appendix or other references to talks and papers so that they can study up on their own. But bringing all that into one document is obviously going to be too much.
So is it fair to say that the with the white paper, if you're thinking of building a chiplet-based product, this at least tells you what is the universe of factors to that you should consider?
Yeah, that's right. That's how I would phrase it.
And that at least and ranked in sort of priority one, priority two, at least the highest priority things that these are the factors you need to consider in aggregate in order to build a product.
Yeah, exactly.
Okay, thank you.
So I have one more slide just as a summary, and as I said, I'll send out those slides afterwards. I think I mentioned it before, but if any of you are interested in joining us and helping with these discussions, we do meet every week just after the general meeting, so 9 a.m. Pacific or 12 p.m. Eastern time. I put in the link here, and there are also these reminders going out every week. And also at the bottom here, I put in a link to the Google Drive where we have the white paper and other materials such as the summary from those 9 company talks, as well as a link to our meeting minutes and recordings if anybody wants to look that up.
Hey, Marek, just one comment on your sections in the document in the white paper.
Yes. Yeah.
They do. It does seem like you're dealing with every issue or all those different topics, but you don't seem to have in a section apart from introduction of pulling together how we could execute in creating this ecosystem, i.e., my getting started point. So I don't know if you want a
I
section in
see.
there on how we can actually get this established in a gradual way, rather than an explosive way of everything's ready to go in one fell swoop.
Wait,
That's a great
Alan,
point. Yeah, and maybe that could be even kind of a like where do we go from here, or a section like this after like realizing okay this is what has to happen. If this is something that you think you could take a first stab at? Like, I'd
Yeah,
appreciate that
no,
a lot.
I possibly could. I mean, mentally, I'm just thinking, it's like I think the IP players today are the ones that can, that already build test chips, and if they built and sold chiplets, they're the first ones that could monetize this, and it could be a sales tool for them. So it's like saying, how do we get all those players into the game? And
Yep.
at different points is when different people can start to benefit from it, so to speak. And then we've got an organic way of getting there rather than needing some miracle of everything coming together in one go.
Hey,
Yep.
Alan,
No,
did you
that's
mean
that's
getting
fair.
started on a product or getting started on the ecosystem? Which one did you
It's,
mean?
it's, it's it's really getting started in the ecosystem because, like I say, I talk to the end customers and they just see all of these points that we're highlighting in the white paper, and they're going, I need all of these to be correct for me to actually decide to not design a monolithic die and to go for a chiplet solution instead. And
Wait, so to
where
help you build a product, you're talking about how to use the ecosystem to help you build a product, right?
no, I'm just saying
You're not.
I'm just saying to get those end customers to use chiplets, you need to have everything answered. But you can't get everything answered unless every different parts of the ecosystem start to answer these various pieces. And I'm saying there may be an organic way, like IP providers today can make chiplets that they can sell. Like Cash's point is, there are no chiplets for anyone to buy. And so it's a case of, um, you know, and the other one is, hey, don't, Mr. Customer, still design and build a monolithic die, but make your first prototype with chiplets because it's going to lower your design costs and shorten your time to market. That may be a way of getting them started rather than say, chuck away your monolithic die and go wholeheartedly to chiplets. So it's this getting started strategy for customers and for the players that are, the companies that are going to add to this ecosystem. It builds it's more of it's how do we do this organically? Because I don't think you can do this explosively in one foul swoop where customers suddenly say everything's answered, I'm going to start doing this. So you've got to work out an organic path to get there. Or Intel comes along and says that we're going to lay it all out for everybody, or one of the big guys, and you're just going to do it the Intel way, which is obviously the other way. It's a de facto standard forced by one of the incumbents, which I think we've got so much better going on here with all the experts from all the disciplines collaborating openly. And so we need to work a way of making the open approach, collaborative approach work. And I think that needs to be more organic. And this white paper could bring that nuance to this. To how do we tackle this?
On that bright note, that's a good.
All right.
Marek, thank you. Everybody else, have a great weekend,
Absolutely.
everyone.
Yep. Bye, everyone.